Anthropic's source code was accidentally exposed to the public via a .map file committed to the NPM registry. To understand why this matters, look at how developers currently use AI. Standard Claude Code and Copilot operate on a strict reactive loop. They sit idle until you explicitly type a prompt and ask for help. But the leaked Breeze and Conversation TypeScript files reveal a different architecture. They point to a persistent, always-on daemon running silently in the background. Instead of waiting for a prompt, this system parses your system logs, observes your keystrokes, and executes tasks entirely on its own. The leak shows that Claude Code is moving from a discrete terminal tool to a background process monitoring system-wide activity. Building an always-on agent creates an immediate engineering problem. Continuous observation generates a massive volume of raw telemetry. If you feed all of that into an LLM, you instantly flood its context window. Anthropic engineered around this bloat by splitting the architecture into two distinct systems, an active execution engine and an idle memory manager. The active component is called the Kairos agent. It is a persistent process running 24/7 to handle real-time observation and immediate execution. The second component is Autodream. This is a heavy optimization pipeline that sits completely dormant until it detects that the developer has stepped away from the keyboard. They operate in tandem. Kairos gathers the noisy, unfiltered daily data, and Autodream distills it into actionable, lightweight context. Splitting active execution from memory management solves the scaling problem. It allows the autonomous agent to process massive amounts of data without exhausting the user's active compute limits. Let's look at how the active state operates. Kairos maintains a baseline process that persists in the background, actively monitoring the system regardless of whether your IDE terminal is currently in focus. This diagram illustrates the core mechanism driving it, the heartbeat. Every few seconds, the system loops an internal prompt asking itself, is there anything worth doing right now? To answer that question, it pulls from three specific data streams: the files you currently have open, the terminal errors you are hitting, and the specific tool chains you are actively using. Kairos continuously processes this telemetry. It builds a real-time understanding of your immediate coding context and your unique stylistic preferences. Then it reaches a critical decision gate. Based on that active context, it autonomously chooses between executing a helpful action or remaining quiet. Crucially, this evaluation happens continuously, entirely without user validation or prompting. This internal heartbeat evaluation is the technical bridge between a static database query and an active team member. When Kairos decides to take action, the leaked source code reveals three specific output vectors. The first is out-of-terminal push notifications. Because Kairos operates as a background daemon, it can interface with external messaging APIs like Telegram or WhatsApp. It can ping your mobile device with status updates or error alerts, even when your computer screen is off. The second output vector is unprompted file delivery. If it identifies a small bug or recognizes the need for a boilerplate script, Kairos can write the code in the background and silently drop the finished file directly into your working directory. The third and most advanced mechanism is pull request subscriptions. Kairos can autonomously monitor your GitHub repository. It can review incoming pull requests, resolve standard merge conflicts on its own, and then ping you for the final review. These capabilities prove that the agent is no longer constrained to the isolated IDE terminal. It is directly interfacing with the broader software development lifecycle. But this persistent execution loop has a fatal flaw. It generates a massive volume of raw memory logs every single day. If the system retains every failed code compilation, typo, and dead end, it will quickly hit hard token limits and degrade the LLM's accuracy. This diagram shows how Anthropic solves this with the Autodream pipeline. It is strictly constrained to trigger only during idle compute time, exactly when you step away from the keyboard. The messy raw logs drop into the first tier of the funnel, memory consolidation. Consider a common debugging scenario. You attempt to fix a bug in an o.js file, and it fails. You try adjusting the API call, and it fails. Finally, you fix the middleware and the code compiles. Autodream reviews that entire trace and consolidates it. It discards the dead ends and retains only the exact middleware logic that successfully resolved the issue. By weaponizing your idle compute, the system performs heavy data refinement without draining your CPU during real-time coding. The refined data then moves into the second tier of the funnel, conflict resolution. In the leaked files, we see how this handles dependency alignment. If Kairos generates code using a generic validation library, and you manually correct it to use the Joy library instead, Autodream extracts that correction from the daily logs. It permanently alters the system's global profile to prefer the Joy library moving forward. Finally, the data enters the third stage, memory compression. This stage aggressively prunes any remaining conversational noise or redundant steps. It leaves behind only high-signal architectural patterns and clear developer preferences. This compression engine is the direct solution to context bloat. It ensures that the agent actively learns your specific codebase from months of use, without ever slowing down the processing speed. This diagram shows how both systems connect into a single unified workflow. The active Kairos daemon constantly feeds raw telemetry data directly into the idle Autodream pipeline. Autodream then takes that heavily optimized compressed context and feeds it back into Kairos' central decision engine. This loop creates a compounding advantage. The agent builds a highly accurate, personalized understanding of your specific project over time. You never have to manually load context or explain your architecture again. This leaked architecture reveals exactly how Anthropic is positioning itself in the broader competitive landscape. As open-source models begin experimenting with persistent tasks, this daemon-based design is Anthropic's direct countermeasure to background agents currently on the market. Software engineering is moving past isolated code snippets toward the daily supervision of autonomous daemons.